Hello friends, I welcome you in lecture number 11 on complex integration. In this lecture we are going to discuss this question of complex integration which was asked in GTU Summer 2020 as well as GTU Winter 2020 examinations. So in GTU Summer 2020 it was asked in this way: find contour integral of 1 by z square where C is the unit circle in counterclockwise direction, and the same question was asked in GTU Winter 2020 exam. Evaluate integral dz over z square where C is the unit circle. So we know that this mod z equal to 1 represents unit circle. So they can ask in either of these two ways, that integral 1 by z square over the contour C, which is represented by mod z equal to 1. On same question can be asked in this way: evaluate integral of 1 by z square over contour C, which is unit circle. So we can do this problem using parametric representation of unit circle, and before that we consider that given function is f of z. So I consider let f of z equal to 1 by z square, and given contour is unit circle. Given contour is represented by mod z equal to 1, and we know that we can write parametric representation of unit circle as z equal to cos theta plus I sin theta, where theta lies between 0 and 2 pi. Or we can rewrite using Euler's formula. We can write cos theta plus I sin theta shortly as e raised to I theta, 0 less than or equal to theta less than or equal to 2 pi. So here theta is our parameter, so we convert everything in terms of theta. So this f of z will be converted in terms of theta by taking z equal to e raised to I theta. Also we will require value of dz. So for that we differentiate this z with respect to theta. So dz by d theta is derivative of e raised to I theta is e raised to I theta times I. Therefore dz becomes I times e raised to I theta multiplied with d theta. So dz will be replaced by I times e raised to I theta d theta, and we also express f of z in terms of theta. So we put z equal to e raised to I theta here. So here we have z square, so we have e raised to I theta square. So this is 1 divided by e raised to 2 I theta, and this we can rewrite as e raised to minus 2 I theta. So f of z is converted in terms of theta, and this dz is also converted in terms of theta. So therefore contour integral of 1 by z square over unit circle. This circle represents that this given contour is closed contour. So this is the notation for integral of a complex function over closed contour. So circle on the integral sign represents the integral over a closed contour. So this is now we replace f of z, that is 1 by z square. This 1 by z square is replaced by e raised to minus 2 I theta, and this dz is replaced by I times e raised to I theta d theta. I times e raised to I theta d theta, and limits of theta are from 0 to 2 pi. So this we can further rewrite as, I first write this constant I e raised to minus 2 I theta into e raised to I theta, that is e raised to minus 2 I theta plus I theta d theta. So this is again becomes 0 to 2 pi e raised to minus I theta integral with respect to theta. So integral of e raised to minus I theta is now e raised to minus I theta divided by minus I, and limits of theta are from 0 to 2 pi. So here I will cancel out, and we are left with negative of e raised to minus I theta, and theta is from 0 to 2 pi. So first we put theta equal to 2 pi, so we have e raised to minus 2 pi I minus minus plus, theta is 0 for lower limit, so e raised to 0 is 1. Now if we simplify this by Euler's formula, this is cos 2 pi minus I sin 2 pi plus 1. So we are familiar with this fact, e raised to minus I theta is equal to cos theta minus I sin theta. So if we compare with e raised to I theta, here theta is 2 pi, so we are using this formula with theta equal to 2 pi. So we have cos 2 pi minus I sin 2 pi. Value of cos 2 pi is 1, sin 2 pi is 0, so this becomes minus 1, and we have plus 1. So integral of 1 by z square over unit circle has value 0. Integral of 1 by z square over mod z equal to 1 is 0. So this problem we have done using parametric representation. We are using the definition of contour integral. So we are converting our integral from f of z to function of theta, where theta is a real variable, and then we integrate with respect to theta. Now same problem can be done using Cauchy integral formula also. So either you can use definition of contour integral, or you can use Cauchy integral formula also. So for that we remember Cauchy integral formula. We know that suppose C is a simple closed contour and function f of z is analytic everywhere inside and on this simple closed contour, then if we are interested in the, and also suppose z0 is a point inside this simple closed contour C. I repeat again, suppose function f of z is analytic at all points inside and on this simple closed contour C, and suppose z0 is some another complex number which is inside this simple closed contour C, then nth derivative of this function f of z at z0 is given by n factorial divided by 2 pi I integral of f of z divided by z minus z0 to the power n plus 1 dz, and this is valid for n equal to 0, 1, 2 and so on. So if we want to use this extended version of Cauchy integral formula for this example, then we can compare our integral with this integral. So if we compare this 1 by z square with this integral, then first we notice that our contour is unit circle with center 0 and radius 1. So it is a simple closed contour. C is mod z equal to 1 for this case. So we can see that given contour is a simple closed contour. Now again we can rewrite this z square as square of z minus 0. So if we compare with this denominator, then in our case z0 is 0. So this C is a simple closed contour and z0 lies inside this simple closed contour C. Now if we compare again with this integral, if we compare these two integrals, then we have to consider our function f of z as constant function. So here f of z is 1 for all z, and if we take f of z equal to 1 for all z, then we know that f of z is analytic everywhere. So therefore f of z is analytic at all points on this circle as well as at all points inside the circle. So here we will consider f of z equal to 1, z0 equal to 0, and we find that function f of z is analytic at all points inside and on this unit circle, and this 0 lies inside C. Therefore we can apply Cauchy integral formula, and if we compare with this power, then we can see n plus 1 is 2, so therefore n will be equal to 1. So here we will have first derivative at 0 will be equal to 1 over 2 pi I integral of 1 by z square dz. So same problem we can do using extended version of Cauchy integral formula, but you must be familiar with this extended version of Cauchy integral formula. So I have uploaded video lectures of this extended Cauchy integral formula also. So if you have not seen that lecture on Cauchy integral formula, I suggest you to watch that lecture first before going for this lecture. So to use Cauchy integral formula, first we consider our function f of z is different for Cauchy integral formula. So to use Cauchy integral formula, here we will consider f of z equal to 1. Now our contour is simple closed contour. It is a unit circle, so circle with center 0 and radius 1. This is just rough sketch, so you don't have to sketch the contour in your examination, but this is just for understanding. This is contour mod z equal to 1, that is circle with center 0 and radius 1. So we can see that f of z is 1 for all z. So function f of z is analytic at all points inside and on this simple closed contour mod z equal to 1. So clearly f of z is analytic at all points inside and on C, which is mod z equal to 1 in this case, and this point 0 lies inside C. So we can see that 0 belongs to C, or we can say that 0 is interior to this unit circle. So therefore by Cauchy integral formula, we are using extended version of Cauchy integral formula, but we will write that this is by Cauchy integral formula. Now here we have z square, so we can write in this way: integral of f of z divided by z minus 0 to the power 1 plus 1 over circle mod z equal to 1. This is equal to here we consider 2 pi I divided by n factorial. Now here n plus 1, if we compare this with n plus 1, then we have n equal to 1. So here we consider first derivative at z equal to 0. So here we are using this Cauchy integral formula, that integral of f of z divided by z minus z0 raised to n plus 1 equal to 2 pi I divided by n factorial, nth derivative at z0. So in our case z0 is 0 and n equal to 1, so here I will write 1 factorial. So now I take a value of f of z, which is 1 here, so I put f of z equal to 1. So therefore integral of, if I take f of z equal to 1, I have z minus 0 square dz. Here I take f of z equal to 1, and 1 factorial is 1, 2 pi I, and derivative of f of z equal to 1 is 0, so I have 0 here. Because f of z is 1, so f dash z is 0 for all z, therefore f dash 0 is also 0. So therefore we obtain that integral of 1 by z square over unit circle is 0 by Cauchy integral formula. So same problem we have done using Cauchy integral formula. So either you can use definition of contour integral, you can go using this parametric representation z equal to e raised to I theta, or you can use this Cauchy integral formula. Both the ways are correct. You will get full marks. Either you are getting either you are using this parametric representation or you are using this Cauchy integral formula. But if it is specified that prove that this is equal to 0 by Cauchy integral formula, then in that case you must use Cauchy integral formula. If it is not specified, then either you can use parametric representation or you can use Cauchy integral formula. Okay, so this is all about this lecture. I hope you like it.